Let us now discuss about the physical properties of benzaldehyde. Benzaldehyde is a colorless liquid whose boiling point is about 452 Kelvin. Its taste is a bitter almond and is also known as oil of bitter almonds. Now let us discuss about the chemical properties of benzaldehyde. Benzaldehyde resembles aliphatic aldehydes in many properties. Because of the presence of benzene ring, the reactivity towards nucleophilic attack at carbonyl carbon is decreased. In this compound, due to the absence of alpha hydrogen atom, which indicates that a carbanion cannot be generated at the alpha carbon. So, this molecule here undergoes an aldol type of condensation which cannot be expected. The presence of benzene ring makes possible the aromatic electrophilic substitution. Benzaldehyde is oxidized to benzoic acid by alkaline permanganate. Here benzaldehyde is oxidized to form benzoic acid, which does not reduce Fehling solution, though it reduces Tollens reagent. Because Ag plus is more easily reduced to Ag than Cu2 plus to Cu plus. Benzaldehyde is also reduced to benzyl alcohol by NaBH4, that is nothing but sodium tetradiborate, or LiAlH4, which is nothing but lithium aluminium hydride. In this reaction, benzaldehyde on reaction with H- forms benzyl alcohol, whereas if benzaldehyde is made to react with ZnHg or in the presence of hydrochloric acid, we obtain toluene. This is known as Clemenson's reduction or also Wolff-Kirschner process. Benzaldehyde condenses with ammonia forming hydrobenzamide. It undergoes addition and addition-elimination reactions with hydrogen cyanide. Sodium hydrogen sulfide with RMgX and with NH2OH, and also with phenylhydrazine and semicarbazine. So benzaldehyde here reacts with 2 moles of ammonia to form hydrobenzamide along with 3 molecules of water. Benzaldehyde reacts with primary amines to form aldamine type of compound called Gibbs base. If you can see here, benzaldehyde reacts with the primary amine, that is RNH2, to form aldamine. When removed water, we obtain C6H5CH double bond NR, which is nothing but a Gibbs base. This is for a general representation of this reaction, and this is the formula having benzaldehyde. This is how the formation of Gibbs base reaction takes place. In the absence of a catalyst, chlorine atom here displaces the aldehydic nitrogen. We can see here. So this chlorine attacks this carbon hydrogen bond, so this hydrogen leaves and we obtain HCl, whereas this Cl attaches with this carbon to form benzoyl chloride. Now let us study about an interesting Cannizzaro reaction. Benzaldehyde undergoes Cannizzaro reaction because of the absence of alpha hydrogen. We take 2 molecules of benzaldehyde in the presence of sodium hydroxide to form sodium benzoate and benzyl alcohol. This Na here replaces this hydrogen to form sodium benzoate, whereas this OH replaces this hydrogen to form benzyl alcohol. This involves self-oxidation and reduction of benzaldehyde when heated and concentrated NaOH. The mechanism which involves the hydride ion transfer from one molecule of benzaldehyde to the other molecule The first step involves the attack of OH- on the carbon atom containing the oxygen. So, this oxygen forms a bond with carbon, and this double bond has to shift to form the lone pair on the oxygen. This is nothing but the nucleophilic attack of the OH- ion on the carbonyl carbon. The second step involves the hydrine ion transfer from the anion to the carbonyl carbon of another molecule. So, the lone pair present on the carbon atom has to shift and attack this carbon. So, this oxygen's double bond has to shift and form the lone pair. So, since we got 2 electrons from this carbon atom forms a double bond with this oxygen, and this hydrogen has to leave and attach here. The third step is nothing but the benzyl oxide ion picks up the acidic proton from benzoic acid to give benzyl alcohol.